teachers, welcome to my video. Today I'm going to be discussing math manipulatives with you, predominantly algebraic tiles with the use of linear equations. First we have a small square. This small square represents 1. If you flip it on the red side, it's a positive. You flip it over to the yellow side, it becomes a negative. There also are long rods. These rods represent x, or our variable. Another option of algebraic tiles we have are these. These are called x squared, which we won't be using today, but they're good to know about as well. You know that they are x squared because you take one of these x's here and one of these x's here, and these two sides make it x squared. So this brings me to the concept of zero pairs. If we have a red tile here, we know that's a +1. The red is positive. And if I add this here, we know the yellow is negative, and that's a -1. This +1 and -1 cancel each other out, and that is called a zero pair. We use zero pairs a lot when using algebraic tiles because we want to try and isolate our x, and often the easiest way to isolate our x is to get rid of the individual numbers that are on the same side as it. I think the best way to help explain this further is by using an example. So we'll use our first example here, 4x = 12. So we'll get our 4x. We know that these rods are x's. So what we have to do first is isolate the x. Luckily, we only have x on this side. There's no other numbers that we have to worry about. So the best way to isolate x would be to break this up into 4 groups. So if we move these tiles, we now have 1 group, 2 groups, 3 groups, 4 groups. As with anything in algebra though, once we do something on one side, we always have to do the same thing on this side. So we have to break this into 4 groups.
So you can see here.
This goes with this goes with this, here and here, here and here. We break this side up into 4, so we have to break this side up into 4. Through this, you can easily see that 1x = 3, 4x = 12, but 1x = 3. This is an example in our New Brunswick curriculum for ax = b, which is found in the first option. So that's how you do this one, just to isolate. Okay, now we're going to set up another example of the New Brunswick curriculum, which is ax ± b = c. So first we're going to set up our linear equation. So 2x, as I mentioned earlier, yellow is negative and red is positive, equals. So we have 2x, 3 small squares in the yellow for negative, and a +7 small squares to show it. So when I look at this, it's clear that the equation is not balanced. So what can we do is we can add things to both sides to help isolate this x, these x's here. So what can we add to both sides? As we mentioned before, are zero pairs. So what I'm going to do is add 3 positive cubes to this equation. So these cancel out, and these cancel out. But when working with algebraic tiles and linear equations, what I do to one side, I must also do to the other. So over here, I must add another 3 positive tiles. I add 3 red here, I have to add 3 red here. So what happens next? Well, these cancel each other out. What we have left is 2x = 10. So if I rearrange this equation, I can rearrange it. This lines up with this, and this lines up with this. This is equal, this is equal, this is equal, and this is equal. So what do we have left with? 1x equals 5.